Hello students, this is the new concept, that is mean value theorem. Okay, what is that? Mean value theorem. So this is 3 marks concept, and very important. So out of this concept, one 3 marks question will be arrived from your annual examination. Okay, so here mean value theorem is the thing, but there are two theorems are there. The first one is Wrongs Theorem. Second one is mean value theorem. Is clear that? So this is the actual mean value theorem. Is clear that? So first of all, we discuss what is the Wrongs Theorem. Okay? So this is only definition and graph is there. The details study is in your higher education. Is clear that? So here the Wrongs Theorem. This is let f be the function f from closed interval ab to r. So closed interval ab to r. So r is the real number. This is function from closed interval ab to r be continuous on closed interval ab and differentiable on open interval ab. See that it is continuous on closed interval ab and it is differentiable on open interval ab such that f of a is equal to f of b. So function of a equal to function of b where ab belongs to r. So a and b are the real numbers. Then there exists some c in open interval ab. So c in open interval ab such that f dash of c is equal to 0. So this is the statement of this Wrongs theorem. Is clear that? Here see that this is the graph of Wrongs theorem. Is clear that? Along x axis, y axis. So this is one graph. This is one curve. So here this point is said to be slope of tangent. The slope of tangent you already studied in geometrically. People are studying first question, that is about slope of tangent. Okay, but in the differentiation, what is slope of tangent? So that is we study in application of derivative in detail. We study in slope of tangent. Okay, so here see that a and b are the end points. A and b are the end points, and c is the middle point. Is clear that? Here closed interval ab, f should be continuous on closed interval ab. The function is always continuous on closed interval ab, students, remember that. Okay, and function is differentiable on open interval ab because derivative is said to be this like that, this point. Is clear that? That's why. So any function is differentiable on open interval ab and it is continuous on closed interval ab. Remember that every continuous function is a closed interval and every differentiable function is always open interval. Is clear that? So here, for all c belongs to, c is the one point. For all c belongs to open interval ab. Why open interval ab it is? Because this is the concept of derivative. That's why we verify the Wrongs theorem by using differentiation. That's why your answer should be for any point c belongs to open interval ab. Open interval ab is nothing but that is a differentiable intervals. Is clear that? So we use differentiation. That's why the point c belongs to open interval ab because open interval ab is a differentiable interval. Is clear that? So our answer should be in terms of c. So c is belongs to a comma b, or c is lies between a to b. So this is Wrongs theorem. So the f dash of c is equal to 0. The function. So already we know that the derivative. Actually this is the application of derivative. Like that. Okay. So here the extended theorem, here the f of a equal to f of b. You can take the end points. A is said to be a and b are the end point of the interval. You can take function of a and function of b. Both are equal. If the both are f of a and f of b are equal, then our Wrongs theorem is exist. Then our Wrongs theorem is exist. Then we show that f dash of c equal to 0. Then we will find some point c that c belongs to open interval ab. This is the verification of Wrongs theorem. It's clear that suppose f of a is not is equal to f of b. Next what? Here f of a equal to f of b, then Wrongs theorem is verified. So then according to procedure you should verify the Wrongs theorem. Suppose f of a is not is equal to f of b. In that case we again form mean value theorem. So mean value theorem is the extension of Wrongs theorem. Suppose f of a is not equal to f of b, then we use mean value theorem. What is mean value theorem? This is also same. Let function from closed interval ab to r be continuous on closed interval ab be differentiable on open interval AB, then there exists here f of A are not there. Then there exists C in AB. Here also the point C is lies between open interval AB such that f dash of C, this is the derivative, such that f dash of C is equal to f of B minus f of A divided by B minus A. So here see the graph. So x axis, y axis. So we can take one graph. So here A, B, the C, the point C lies between A to B open interval. Obviously it is differentiable. Okay. So here see that this point should be A function of A, C function of C, B function of B. By using slope of tangent, what is the formula for slope of tangent? Slope of the slope is equal to y2 minus y1 divided by x2 minus x1. That's why f dash is said to be slope of the tangent. So slope of the tangent is equal to y2 minus y1. What is your y2? F of b minus f of b. y2 minus y1 divided by x2 minus x1. This is the theorem. F dash of c equal to f of b minus f of b divided by b minus a. Is clear that? So this is the these two are the theorem. Is clear that? Student, remember that the statements are very important. Is clear that both the statement are same, but in Wrongs theorem you can apply function of a equal to function of b. Suppose function of a equal to function of b, then we find f dash of c, then c belongs to open interval ab. This is the procedure. And in mean value theorem, as it is, you can write the continuous and differentiable interval there, but here there is no f of b point of view. Obviously here f of a is not equal to f of b. Then again we find f dash of c equal to, by using this formula, f of b minus f of a divided by b minus a. Then for all c belongs to open interval ab, as it is same. So here by using this theorem we find some of the examples. So here by using Wrongs theorem 2 examples are there. By using mean value theorem 3 examples. So out of 5 examples, 1 example will be coming for your annual examination. This is very easy concept. Is clear that? So detailed theory of this mean value theorem should be you studied in your higher education. Is clear that? Here only definition graph. Definition graph. Is clear that? If you need any detail, so you go through your NCERT textbook. Is clear that? First of all, you read definition. Wrongs theorem is nothing but both the definitions are same. Here continuous, differentiable same. And here f of a equal to f of a, then we apply f dash of c equal to 0. Here directly we can apply f dash of c equal to that formula, f of b minus f of a divided by b minus a. Is clear that? So this is definitely regarding the Wrongs theorem as well as mean value theorem. Is clear that? See that the mean value theorem is the extension form of Wrongs theorem. Is clear that? So here why it is extension form of Wrongs theorem? So we f of a equal to f of b, then we apply Wrongs theorem. Suppose f of a is not is equal to f of b, then we can find another theorem, that is mean value theorem. Is clear that? So first write down these two definitions and two graphs. Okay? Then we will discuss the example based on these theorems. Okay? Right. So students, this is the example. It is verify Wrongs theorem for the function f of x is equal to x square plus 2x minus 8 for all x belongs to minus 4 comma 2. Here for all x belongs to minus 4 comma 2 is nothing but for all x belongs to a comma b, closed interval a. So here the a equal to minus 4, b equal to 2. Is clear that? According to statement. This is the verification of Wrongs theorem. This is a very easy example, and this is also very important example for your annual examination. So I can solve by using Wrongs theorem. There are only 2 problems are there. I can solve this problem. Then you people try once. Okay. So carefully observe the procedure of this example. Okay. Here. First of all, what I will do that verify Wrongs theorem for this function. What is the function? F of x equal to x square plus 2x minus 8 for all x belongs to closed interval AB. Here a is minus 4 and b is 2. So first of all, we write the description. So this is a compulsory statement. So let us consider let if f of x equal to, if the function f of x equal to x square plus 2x minus 8 is continuous on continuous on closed interval AB. Closed interval AB is nothing but what is your AB? Minus 4 comma 2. And differentiable on open interval AB. Open interval is nothing but minus 4 comma 2. It's clear that this statement should be you can write. Here in this statement, what is that? If f of x is equal to x square plus 2x minus a is continuous on closed interval a comma b. A is minus 4, b is 2. And it is differentiable on open interval minus 4 comma 2. Open interval minus 4 comma 2. And next, what we need to check that? We need to check that f of a equal to f of b. Okay? Here, what is your a? A is your minus 4 and b is 2. Okay, then we find f of a and f of b. F of a is nothing but f of minus 4. That is equal to function of x is said to be x square plus 2x minus 8. Instead of x we replace 4. That is nothing but minus 4 whole square plus 2 into minus 4 minus 8. Minus 8. Okay, so that is equal to minus 4 square is 16. This is minus 8 minus 8. So 16 and 16 get cancelled. This should be 0. F of a is 0 and f of b you can find what is the value of f of b? F of b is nothing but f of 2. Instead of x you can write x square plus 2x minus 8 is 2 square plus 2 into 2 minus 8. It's clear that here also 4 plus 4 minus 8 that is equal to 0. Let's see that. Thus, f of a equal to f of b. F of minus 4 is equal to f of 2. It's clear that. First step what to do that? The function should be continuous. Obviously this is polynomial function. So polynomial function should be continuous on closed interval AB. If the function is continuous, then automatically it is differentiable on open interval AB. Then what we have to find? F of a and f of b. Here f of a equal to 0, f of b equal to 0. And thus f of a is equal to f of b. That's nothing but f of minus 4 equal to f of 2. Thus the Wrongs theorem is exist. Is clear that? Thus Wrongs theorem is exist. Thus f of a equal to f of b. Okay? Then f dash of c equal to 0. So what is f dash of c? So already here f of x is there. What is your f of x? X square plus 2x minus 8. Okay, or else we can write it. Next step is now f of x should be, already we know that x square plus 2x minus 8. And what is your f dash of x? Derivative of the function. Derivative of x1 is 2x. Derivative of 2x is plus 2. Derivative of 8 is 0. This is the f dash of x. It's clear that? So here f of a equal to f of b. Then there exists such that f dash of c is equal to 0 is our statement. Is clear that? What do I do that? F dash of c equal to f dash of x nothing but that one. F dash of c is 2c plus 2 is equal to 0. Instead of x we can replace c. F dash of c equal to 0. Then 2c is equal to minus 2. C is equal to minus 1. This belongs to open interval minus 4 comma 2. Obviously, minus 1 belongs to open interval minus 4 comma 2, lies between minus 4 to 2. Thus, the Wrongs theorem is verified. Thus, Wrongs theorem is verified. Wrongs theorem is verified. This is the procedure. It's clear. Very simple procedure. It is clear there. So once again I can say that. So here we can take this should be compulsory. If the function f of x equal to x square plus 2x minus 8 is continuous on closed interval minus 4 comma 2, continuous on closed interval AB, and it is differentiable differentiable on open interval a b minus 4 comma 2. Here a equal to b equal to, then you can find according to the Wrongs theorem f of a and f of b. Then we compare f of a equal to f of b. If f of a equal to f of b, then what is your f of x? That one f dash of b is like that. Then what is the statement? F dash of c equal to 0. Then you can find c for all c belongs to open interval a b. This step should be compulsory. Suppose you people forget c equal to minus 1, that belongs to minus 4 comma 2. That belongs to minus 4 comma 2. This step you can forget, then automatically deduct 1 mark. It's clear that this is very important. For all c belongs to minus 4 comma 2. It's clear that this is the procedure. This is very important example, friends. Make note of this example. If you have any doubt, and ask. Okay, right now. Friends, this is also same example. Verify Wrongs theorem for the function f of x equal to x square plus 2 for all a is minus 2, b is 2. That is closed interval a comma b. A is minus 2 and b is 2. So this is also same example. That these two examples are very important in Wrongs theorem. This is very important. Same procedure, above same procedure. The f is continuous on closed interval a b, f is differentiable on open interval a b. Then we can find f of a, f of b, and equate f of a equal to f of a. Suppose f of a equal to f of b holds, then such that f dash of c equal to 0. What is f dash of c? We need to find f of x, f dash of x, f dash of x. We need to find f dash of x, and automatically f dash of c. So equate f dash of c equal to 0, then c belongs to this point. Suppose c does not belong to minus 2 comma 2, then Wrongs theorem is not verified. This is suppose. Okay. If c belongs to this interval, open interval minus 2 comma 2, then Wrongs theorem is verified. It's clear that these two examples are very important. Okay. Write down this. Students, here this example, examine the Wrongs theorem is applicable to any of the following functions. So here we need to verify first, second, third function. So either Wrongs theorem is applicable or not applicable. Okay, so here friends, see that the first example f of x equal to greatest integer x. So already we know that the greatest integer function is not continuous. The greatest integer function is not continuous. And greatest integer function is not differentiable. Already we know that, and also we check that the greatest integer function is not continuous. It's clear that that's why the function is not continuous, the function is not differentiable. Automatically Wrongs theorem is not verified. Same, the function is not continuous function and not differentiable, so automatically the function should be Wrongs theorem is not applicable. Here we did check. So here first and second I can write. First one, let f of x is equal to greatest integer x is not continuous function. Is not continuous on closed interval a b 5, 9. If not continuous function, then automatically is not differentiable function. And also f of a equal to f of 5 is equal to f of 9. This you need to verify. So f of 5 is equal to greatest integer of 5 equal to greatest integer of 9. So greatest integer of 5 is 5 is equal to 9. This is also not equal. Thus Wrongs theorem is not applicable. Wrongs theorem is not applicable. Is clear that? Like that, similarly in 2. In 2 is also f of x equal to greatest integer x for all x belongs to this one. Here also the Wrongs theorem is not applicable because this is also greatest integer function. The greatest integer function is not continuous. Is clear that? And f of a equal to f of a, and greatest integer of minus 2 is 2, greatest integer of 2 is 2. Then f of a is also not equal to f of a. Okay? And third one, this is polynomial function. Let f of x is equal to this one polynomial function x square minus 1 is continuous. Obviously this is continuous on closed interval 1 comma 2 and differentiable on open interval 1 comma 2. This obviously because this is polynomial function. Polynomial function is continuous on closed interval and differentiable on open interval, and we need to check f of a equal to f of a. Here f of a, f of 1 is equal to, what is that? 1 minus 1 equal to 0. F of 2 is equal to 2 square is 2 square minus 1, that is 3. Here f of 1 is not is equal to f of 2. This is not verified. Automatically the Wrongs theorem is not applicable. Thus Wrongs theorem is not applicable. This is the example procedure. This is one skill based question is there. This is not important for your examination. Previous two examples are there now. One I can solve and try yourself one example is there. So that two examples are very important. Okay. So just see that examples. Is clear that these three examples are not applicable in Wrongs theorem. Is clear that? Right. Students, this is the example based on mean value theorem. Second one. So Wrongs theorem is over. That two examples are very important example. So keep in your mind, and the Wrongs theorem. So this is mean value theorem. This is also very important example for 3 marks. Okay, write by mean value theorem. Okay, same procedure I can solve. Say that let f of x is equal to x square minus 4x minus 3 is continuous on, this is continuous on closed interval AB. Closed interval AB is nothing but 1 comma 4. This is polynomial function, always continuous, and differentiable on open interval AB, open interval 1 comma 4. Okay, here we don't check f of a equal to f of a, but we need to find f of a equal to f of a such that what is your formula? F dash of c is equal to f of b minus f of a divided by b minus a. Is clear that? Then what you need to check that? F of a. Now f of a is nothing but f of, what is your here? Here a is equal to 1, b equal to 4. Now f of a equal to f of 1. F of 1 should be put 1 in this one. 1 square minus 4 into 1 minus 3 is equal to, so here 1 minus 7 is equal to minus 6. Is clear that? And f of b is equal to, f of b is said to be 4. So 4 square minus 4 into 4 minus 3. 4 square is 16 minus 16 minus 3. Is clear that? So here put 4 is in this one. 4 square minus 4 into 4 minus 3. 6 here plus 6 minus 6 get cancelled. So minus 3. So f of a is minus 6. F of b is minus 3. Okay? And again here we know the value of a, we know the value of b, b and a, we know the value of f of a, we know the value of f of b, and we need to know f dash of c. Before going to f dash of c, first we will find f dash of x. Now f dash of x is, what is your f of x? X square minus 4x minus 3. And what is your f dash of x? Your f dash of x is, what is that? 2x minus 4. Is clear that? Thus f dash of c is equal to f of b minus f of a. What is your f of b? F of b is minus 3. Minus f of b is, what is your f of a? Minus 6. Minus of minus 4 divided by b minus c. B is 4 and a is 1. See that? F dash of c equal to f of b. The value of f of b is minus 3. Value of f of b is minus 6. F of b minus f of a. Use bracket. Okay? So f dash of c. What is the value of f dash of c? F dash of x is 2x plus 4. F dash of c is 2c minus that is equal to. So here minus 3 as it is, minus 3 this is plus 6 divided by 3. Okay, 2c minus 4 equal to this is 3 divided by 3. Minus 3 plus 6 is plus 3. So 2c minus 4 equal to 1. 2c equal to 1 plus 4. So 2c is equal to 5. Is clear that? And c is equal to 5 divided by. C is equal to 5 divided by 2. 5 divided by 2 is nothing but here the value 1 point something. So obviously C belongs to open interval 1 comma. This step should be compulsory. Suppose you forget belongs to 1 comma 4, then you lost 1 mark. Is clear that? C belongs to C is equal to 5 by 2. 5 by 2 is nothing but either 2 point something. So that always belongs to 1 comma 4. So thus mean value theorem is verified. Mean value theorem is verified. This is the procedure. So you compare to Wrongs theorem. This is different procedure. In Wrongs theorem, up to this same, we can find f of a, f of b, and equate f of a equal to f of b. Suppose f of a equal to f of b, then we will continue f dash of c equal to 0. The procedure. Here, same up to this procedure is same. Then you can find f dash of c. So f of a, f of b, we know the value of a, b, f of a, f of b, but we don't equate f of a equal to f of b. Obviously, those are not equal. Then we go for this procedure. Then f dash of x equal to, we can put the value of f of a, f of b, b and a. Then we solve c equal to 1 point coming for all c belongs to open interval this one. Okay. Thus mean value theorem is applicable. This is one procedure. Is clear that? Wrongs theorem and mean value theorem. Only 2 theorems are there. Okay. Remember that procedure. If you have any doubt, and ask them. Okay. First of all, write down this example. Friends, this is also one very important example is verify mean value theorem for the function x cube minus 5x square minus 3x in the interval 1 comma 3. This is also example based on mean value theorem. This is second example on mean value theorem. Is there that? So I can solve this example. So same procedure, there is no change. So first of all, let us consider f of x equal to, what is the function? X cube minus 5x square minus 3x is continuous on closed interval AB is nothing but 1 comma 3. Closed interval AB is 1 comma 3 and differentiable on open interval AB 1 comma 3 such that so what is its form? Such that f dash of c equal to f of b minus f of a divided by b minus a. Then we need to find the value of c. The value of c belongs to open interval this one. So then we need to find c. Then we put we know the value of f of b, f of a, b and a. So already we know that a and b value, like a is equal to 1, b equal to 3. No, here no, a equal to 1 and b equal to 3. Then we find f of a. F of a is nothing but f of 1 is equal to. So what is that? Instead of x put the value of 1 is nothing but 1 cube minus 5 into 1 whole square minus 3 into 1 is equal to 1 cube is 1 minus 5 minus 3 is minus 7. This is equal to minus 7. This is value of f of a. And f of b is nothing but, what is the f of b? F of 3 equal to 3 cube. Instead of x we put the value of 3. So 3 cube minus 5 into 3 square. 5 into 3 square minus 3 into 3. Is clear that? Then that is equal to 3 cube is 27 minus 5 3 square is 9 5 is 44. So 45. So this is a 9 5 is a 45 minus 9. So here 47 as it is, 45 minus 9 is minus 45 minus 9 is minus 54. It is equal to minus 27. f of b. Okay, and also we find f dash of x. What is the value of f dash of x? Then f of x would be this one. F dash of x is derivative of x cube is 3x square. 3x square. Okay, and derivative of 5x square is, so take 5 common, derivative of x square is 2x. 2 into 5 is 10, that is minus 10x, and derivative of 3x is minus 10. Okay, then f dash of c equal to f of b minus f of b. What is the value of f of b? Minus 27 minus, what is the value of f of a? Minus 7 whole divided by b minus a, 3 minus 1. So that is equal to f dash of c equal to, first we find minus 27 plus 7 divided by 2. That is equal to 20 divided by 2. That is equal to 10. Is clear? Minus into minus plus 7. Minus 27 plus 7 is 20. So 20 divided by 2 is 10. F dash of c equal to 10. Therefore, the value of f dash of c. What is the value of f dash of c? F dash of c is f dash of x. Instead of x, we put the value of c. That is equal to 3c square minus 10c minus 3 is equal to 10. Value of f dash of c is 3c square. Instead of x, we put the value of c. F dash of c equal to 3c square minus 10c minus 3. Okay, then 10 subtract to left hand side will become 3c square minus 10c plus this is also minus 7. This is minus 3. Sorry, this is minus 7. This is minus 27 plus minus 20. This is minus 7. This is minus 7. So minus 10 subtract to this side, it will become plus 10. Plus 10 minus 7 is plus 7 is equal to 0. Is clear? Minus 10 subtract to left hand side, it will become plus 10. Plus 10 minus 3 is plus 7. This is the quadratic equation. 3c square minus 10c plus 7. Then we factorize by using factors method. We find the value of c. Okay. So here I can write 10 is nothing but 3c square minus 3c minus 7c plus 7 equal to 0. This is factorization. See that minus 3c minus 7c is minus 10c. Minus into minus plus 3 into 7 is 21. So 3 7s are 21. This is over. Then take 3c as a common. The remaining term is c minus 1. Sorry. C minus 1. Take 3c common. So 3c common, remaining c minus 1. And this two term take minus 7 common. Then again this is also c minus 1 is equal to 0. Here 3c minus 7 equal to 0. 3c minus 7 one term, and another term is c minus 1 is equal to 0. It's clear that either 3c minus 7 equal to 0 or c minus 1 equal to 0. So c equal to 7 divided by 3 or c equal to 1. C equal to 1. It's clear that? See that c equal to 1, that does not belongs to open interval 1, 3. This is does not belongs to open interval 1, 3. This is open interval. C equal to term, because c equal to 1 is does not belong to that one. Here suppose this is closed interval, then it always belongs to. This is open interval is nothing but excluding the end point. That's all. C equal to 1 does not belong to this one. Obviously 7 by 3 is 3 1s are 3 2s are, this is 2 point something point. So obviously this belongs to 1, 3. Okay, that is c equal to 7 by 3. This is not possible. This is not possible. Leave it. C equal to 7 by 3. That belongs to open interval 1, 7. Thus, mean value theorem is valid. Mean value theorem is valid. This is the first one. This is one of the example. See that bit complicated example. Okay. Solve this example. Then again one example is there. So I will give that example as your homework. Mean value theorem. So already Wrongs theorem one example I solved, and I will give it to you people one example. And next Wrongs theorem, mean value theorem, 2 examples I can solve, and 1 example for you. Okay. First of all, write down this example, then I will give it. Okay, write down. Students, this is also example. Verify mean value theorem for the function f of x equal to x square in the interval 2, 4. This is very easy example and very important example. Okay, so you people try this example. Okay, so already I solved 2 examples on mean value theorem. So you can solve this example. Okay, and here examine the applicability of mean value theorem for the following. First one, like that same in Wrongs Theorem, f of x equal to same, f of x equal to same function, same function. Just we need to verify the mean value theorems are applicable or not. Obviously, first and second example, mean value theorem are not applicable because this is greatest integer function. The f of x equal to greatest integer function is not continuous on this operator label. Automatically not continuous, but the mean value theorem is not applicable. This is also not continuous, not applicable. But you need to check third one, f of x equal to x. This is polynomial function. This is continuous. This is differentiable. Then find the value of f of a, find the value of f of b. Then apply mean value theorem. Okay, I think this is applicable. Mean value theorem is verified. So you people try this example also. Very easy examples. Okay. So students, see that in this part 3 marks examples are very important, and Wrongs theorem 2 examples, Wrongs theorem 2 examples, mean value theorem 3 examples, mean value theorem 3 examples out of 5 examples. So mean value theorems, that 2 examples. I can solve 1 example, and you people homework example is 2 examples are very important. And in mean value theorem, so this example and I can solve 2 examples. That 5 examples are very important. This is not important like that. Just you solve that one. Okay. So out of 5 such examples, 1 example. Out of 5 such example, 1 example, 3 marks. Fixed question. Okay. So these are very easy. Parametric form also very easy, and this is very easy. So you people try. Okay. So the continuity and differentiability chapter is over, but the miscellaneous part is there. Here also the miscellaneous examples are coming from your annual examination. Like that. Suppose in question paper there is no question paper on mean value theorem, then automatically it will be in miscellaneous. Or miscellaneous in parametric form, in parametric form also there is no example, then automatically miscellaneous examples is included. Okay. Some of the important miscellaneous examples I discussed in next class. Then you people press some examples. Okay. So this is all about continuity and differentiability. Tomorrow I will discuss some important example on miscellaneous. Is clear? Okay. Thank you, students.